Hello everyone, this is Dr. Elmatics. Welcome to today's lesson 2 on quadratic equations, where we're going to learn how to solve quadratic equations by completing the square. So if you haven't subscribed to this channel, please do so now so that you don't miss out. Otherwise, let's begin. So solving quadratic equations by completing the square is a technique that involves the transformation of the structure of a quadratic equation. Easy. So usually when we are given a quadratic equation, it always takes the structure ax squared plus bx plus c equal to 0. But when we're using this technique, we are trying to transform this structure so that our equation appears in the form a x minus p squared plus q equal to 0. So this technique of changing the structure into something like this, we call that completing the square. So what we're going to learn is how do we actually complete the square for a given quadratic equation? How do we complete the square? How do we write a quadratic equation which is in this form into one which appears like that? So this structure is very useful in solving all different types of quadratic equations, whether they have solutions or they do not have solutions. So in order to demonstrate how this technique works, I'm going to do some few examples, and the first example I will use a type 1 or a category 1 equation. So what you can be given in exams is something like this. So you can be given a problem where you are asked to solve the equation x squared plus 8x equal to 1. So how do we go about solving this using the technique of completing the square? So one of the things that is common between all the different techniques is that all the time when you have to solve a quadratic equation, you must make sure that it's always written in its general form. That is the form ax squared plus bx plus c equal to 0. So you are going to take that. So we'll bring negative 1 this side to become negative 1 to give us that. Then now let's solve from here. So how do we solve? So when we're using the technique of completing the square, one of the things that we need is that the coefficient of this term, which is the quadratic term, we always prefer this term to be always plus 1 all the time when we're to use this technique. So we are going to see how then do we solve if an equation already satisfies this condition. Easy. So the process goes as follows. So every time when you are asked to solve a quadratic equation using this technique, this is how you proceed. At first, you determine the square root of this first term, the quadratic term, and the square root of that term is x, then you write it down. Then the next thing, you shift your focus and now look at the coefficient of the middle term, or what we refer to as the linear term. So now you shift your focus there and you take the coefficient of that middle term and divide it by 2. So in this case, our coefficient is positive 8. When you divide that by 2, you get plus 4. Then what you do, you enclose all these two terms inside bracket and put a square on the outside. Then the next thing, you put a minus. So you always put a minus all the time when you're using this technique. Then the term that comes after this minus is the term or is the number which is inside the bracket, but when we are writing it next to this negative, we always square that number. Then the next thing, you just drop down the constant that was there and you get to 0. So what we do now, we have to just simplify this. So when we simplify all this, it implies we have x plus 4 squared minus 17 equal to 0. So now you can take 17 that side, so it implies you will have x plus 4 square equal to positive 17. Then the next thing, we have to remove this square. So to remove this square, we know the trick. We always root both on the left and on the right. So when we root here, this square root cancels that one of those and one remains. And here we know that the square root of any number is plus or minus that. So now we can take 4 to go that side. So therefore it follows that x is equals to 4 plus or minus root 17, like that. So you can leave your answers in any form, but at times the examiner will instruct you in what form you should leave your solution, so you will have to stick to that. If they say to 2 decimal places, you will have to take out your calculator and simplify this further. Otherwise, this is how we solve equations by completing the square. But this was a very easy one because it was a category 1 problem. Now let's do another example where we look at a category 2 problem. So now we have another problem where we are asked to solve the equation 2x squared plus 2x minus 1 equal to 0. So how do we go about solving this? So when an equation falls under category 2 or category 3, this is how we proceed. So all the time when we are to use this technique, the requirement is that this coefficient is 1, not 2. So in order to fix it, we divide. So dividing by 2, we have that x squared plus x minus a half is equal to 0. So this is how you always do it whenever the problem falls under category 2 or category 3. So when you are here now, the steps are as obvious. So when the coefficient is positive 1, we know that we start here, find the square root of that, which is x. Then we move on to the coefficient of the next middle term. You take that coefficient and divide it by 2. So in this case it's 1, so divide by 2, you get half. You close these inside brackets and you square on the outside, and after that you put a minus. It's always a minus, remember, and what you minus is this term but squared. So you will subtract half but squared. Then you will drop down the negative half, which is there, equal to 0. So when we simplify, what we get? So we get x plus half square minus 1/4 minus half equal to 0. So let's simplify further. What we get when we simplify further? So these have the same sign, so we can just keep the negative and then add these two. So when you add a half and a quarter, you get 3/4. This all equal to 0. Then the next thing, we transport this the other side. So it follows that x plus half squared is equal to 3/4. So as usual, to remove the square, we root here, we root there. So it follows that x plus half is equal to, the root of this will just become plus or minus root 3/2. So now you can check x the other side. So therefore x becomes minus 1 plus or minus root 3/2. So that's your final solution. So again, if you need it in a new format, this is the solution in set form. If you need it in another form, you just use the calculator to just get the solutions out of this. So the next thing, now we are going to look at the more general example. So this, you can take it as a derivation of the quadratic formula. because now we are going to use a generalized equation as our example 3. So this is one of the good examples that you can use to always practice whether you have understood how to use completing the square in solving problems. So what we're going to solve now, we are going to solve the equation ax squared plus bx plus c equal to 0. So now we're not going to put numbers whether it's a, b, and c, but we're going to consider this and then solve it using the technique that we have displayed. So now let's proceed. So we know that all the time we always require this to be 1. So since here we don't have a positive 1, we have to remove this term by division. So if we divide by a, we have what? So if we divide by a, we have that x squared plus b over ax plus c over a is equals to 0. Then the next thing, we know that whenever our equation has plus 1 here, now it's time to complete the square. So to do that, we take the square root of this first term, which is x. Then you consider the coefficient of the second term, which is b plus b over a. You divide that by 2. So if you divide that by 2, you will get plus b over 2a. Then you put these in brackets, you square, subtract as usual. But what is it that is subtracted? It is this term. So you take b over 2a, then you square, then you bring down plus c over a equal to 0. So now let's simplify what we get. So if we simplify, we get that x plus b over 2a squared minus b squared over 4a squared plus c over a is equals to 0. So now I can take this term here and also that one there. So if I bring these two terms to the other side, what happens? I'll get that x plus b over 2a square is equals to this term. When it's negative here, when it goes there, it will become positive. So I'll write it first to get this, then minus c over a. So what I'm going to do now, I'll try to write this in a more nicer way by combining these into a single equation. So I'll find the common denominator of these, which is 4a squared, and we know how everything goes from here. So we say this into that, it enters one time, times that we get b squared. Then this into that, we remain with 4a times that, we get negative 4ac. So it implies x plus b over 2a squared is equal to that. So now what we have to do is we have to root both sides as usual. So let's root here and let's root there. So what happens? So if we root, we have that x plus b over 2a is equals to plus or minus the root. Here I will keep the root sign only at the top, so I'll have root of b squared minus 4ac. But since the denominator is a perfect square, the root will just simplify and give us 2a. So the next thing that I'm going to do is I'm going to take this term and take it the other side. So it follows that x is equals to minus b over 2a plus or minus root of b squared minus 4ac over 2a. So therefore finally, what is x? So therefore final x is equals to minus b plus or minus root of b squared minus 4ac, all these over 2a. So that's our final answer. So this expression that we have managed to derive here is what we usually refer to as the quadratic formula. So in our next video, we are going to